Hi, accelerated algebra 2, Stirrup here. This is going to be 5B going over quadratic, so we're going to be doing some graphing with these. Look for the patterns that we're doing, especially when we are dealing with the 1, 3, 5 pattern. Okay, so how do you know you have a quadratic? Well, if you have x squared someplace in the problem. Now, if you have x squared in a denominator or under a radical, those would not make it a quadratic. So quadratics would be something like this, or if it was factored out, or if it was in vertex form. So something like that. Those are all quadratics. Okay, so x squared is what we're looking for. All right, if we take a look at this, this is our initial parent function. So we can pattern graph, that's fine, but if you start seeing a pattern right away, parent functions typically have 0, 0. And I'm going to show you something called the 1-3-5 rule. Okay, the 1-3-5 rule, how this works is if I have a 1 out in front of my x squared, I pattern graph as 1-3-5. So from here I go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, right 1 up 5, left 1 up 5, and then here's this nice shape. This is our parent graph. So we can shift this up, down, right, left, flip it over, all kinds of things. But we're just going to keep it like this right now. So what happens to the value when this is going to make it go down 5. So any of these values that were here on the parent function, I would have subtracted 5 from. On this one, I'd go up 7. So any of these on our parent function being x squared, I would add 7 to any of those. And that's how you would jump through those tables. So the critical pattern is our a value times 1, 3, 5. And this is how we're going to pattern graph. And our a value falls in a few different locations with our problems. So this is called standard form. And then you have factored form. Okay, so notice your a value is out front. And then you have your vertex form. So that's your vertex form. Okay, so we'll be dealing with those quite a bit in the next couple of slides. Okay, so how's the pattern graph going to be affected here? Well, I have this 1, 3, 5, so I'm going to go 2 times 1, 3, 5. So I'm going to get 2, 6, 10, and that's going to help us when we pattern graph. If I have the 1/2 out there, I'm going to go 1/2 times 1, 3, 5, and I'm going to leave them as improper fractions. So I have 1/2, which is a proper fraction, 3/2, improper, 5/2. And we'll talk more about that when we start pattern graphing later. So take a look if it opens up or down. That's if the a value is positive, up. If the a value is negative, down. Find the vertex. The vertex is usually the letters you use are h, k. The axis of symmetry, so AOS, which is this, is x equals the h value of the vertex. And then the pattern graph works as a times 1, 3, 5. And we're going to work more with that as we progress through this. Please ask questions if you have it. We've already talked about these forms. I think I had h and k there, which, you know, these are just variables. They're using p and q. Okay, so this graph, notice we'd have an hk characteristic for the vertex. The axis of symmetry is the same as the x component here. If the a value is positive, opens up. If it's negative, opens down. So let's see. Describe the transformation. So this is going to go right 3. So that means my vertex is at 3, 0. My axis of symmetry is x equals 3. And then my y-intercept, if I plug 0 in for x, 0 minus 3 is negative 3. Negative 3 squared is 9. That works that way. Okay. Next problem. This is going to go left 4 and upside down. So over the x-axis. All right. So my vertex to this one is going to be negative 4, 0. My axis of symmetry is x equals negative 4. And then my y-intercept, I'm going to plug 0 in. So 0 plus 4 is 4. 4 squared is 16. 16 with a negative is negative 16. This next one, oops, we have 7 comma negative 4 as our vertex. So it's going to go right 7, down 4. Our axis of symmetry is going to be x equals 7. So that's a horizontal line that allows me to crease my parabola over it. And then my y-intercept, I'm going to plug 0 in for my x value. So 0 minus 7 is negative 7. Negative 7 squared is 49. 49 minus 4 is 45. Okay. Next problem, my vertex. So this would go left 5, so minus 5, up 6. So there's my vertex. My axis of symmetry is going to be x equals negative 5. And then if I wanted to find my y-intercept, I'm going to plug 0 in for my x. So 0 plus 5 is 5. 5 squared is 25. Take that and count that negative. So negative 25 plus 6 is negative 19. All right, so let's go ahead and graph it. So this one is going to be negative 3, negative 2 is my vertex. So let's see, negative 3, negative 2 is my vertex down here. And now I'm going to pattern graph. Notice I have an a value of 1. Okay, now up and down this line here is my axis of symmetry. It's this dotted vertical line. Okay, it doesn't really count as part of the graph. It's just something that it reflects over. Okay, so I'm going to pattern graph. Notice that's 1, so I'm going to pattern graph as 1, 3, 5. So from my vertex, I'm going to go right 1, up 1, left 1, up 1. From there, new points, I'm going to go right 1, up 3, left 1, up 3. And that's usually enough. We could keep going. We can go right 1, up 5, left 1, up 5. But typically, we want your vertex and 4 other points defined. Okay. Second problem we'll do here. This one will flip upside down because we have that negative, but we have positive 2, positive 8. So it's up here. My pattern graph is going to be negative 1, negative 3, negative 5. Okay, because of that negative. So I'm going to go right 1, down 1, left 1, down 1, right 1, down 3, left 1, down 3. And again, we found enough points. Oh, we define y across the y-intercept. And again, if we want to put my axis symmetry in there, that's the line I could fold it over on top of itself. It's symmetric about it. Okay. This one I'm going to have a vertex of 4, comma 1. So it moves right 4 and up 1. Okay, remember my axis symmetry is going to go right through that. My pattern graph isn't going to be 1, 3, 5. It's going to be 2 times 1, 3, 5. So 2, 6, 10. So for my vertex, I'm going to go right 1, up 2, left 1, up 2, right 1, up 6, left 1, up 6. There's my parabola. This next problem, I have a vertex of negative 3, so it goes left 3, up 8. I'm going to go left 3, up 8. I do have that axis of symmetry that's going to come straight down right there. And so my pattern graph is going to be negative 1/2 times 1, 3, 5. So I'm going to get negative half, negative 3 halves, negative 5 halves. So what I'm going to do is I'm going to go right 1, down half, left 1, down half, right 1, down 1.5. So there's half, there's 1.5, left 1, and 1.5. And you could went right 1, down 2.5 or 5.5, 5 halves. That's our parabola. Kind of worked out nicely. So what connection is there between the vertex and the axis of symmetry? So h comma k, that's what they always use for it. My axis of symmetry is always x equals h. Okay. Now when you have your parabola that's all factored out, you're going to use negative b over 2a to right, so let's take a look at how this is going to transpire. So negative b over 2a is the axis of symmetry. It's also the x component of the vertex. So the first one we'll go ahead and do it in red. So I have an a value, a b value, and a c value. Is that okay? So I get negative b over 2a. So remember, I'm using negative b over 2a to find my axis of symmetry. So negative 6, that's 6. 6 over 2 is 3, so I get x equals 3. So I draw this, my dotted line. All right, now let's try finding my vertex. So 3 comma something. Well, I'm going to plug 3 in. So 3 squared is 9. Minus 6 times 3 is minus 18 plus 11. So 9 minus 18 is negative 9. Negative 9 plus 11 is 2. So I am at 3, 2. So right here is my vertex. My pattern graph will work as 1, 3, 5. So I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3. And that's how that works. Okay, again, I'm going to use negative b over 2a. So my a value is negative 8, or my b value is negative 8, or 8. So I'm going to go negative 8 times 2 times negative 2. Negative, or that's going to be 8, negative 8 over negative 4. Negative 8 over negative 4 is 2. So here's my axis of symmetry here. Excuse us, red parabola. And then I'm going to plug 2 in. So 2 squared is 4. 4 times negative 2 is negative 8. Plus 8 times 2 is 16, minus 3. So negative 8 plus 16 is 8. 8 minus 3 is 5. So 2 comma 5 is where my vertex lives on this blue one. And we're going to pattern graph. It's going to be negative 2, negative 6, negative 10. Do you see why? Yeah, you're going to multiply that negative 2 by it. So I'm going to go right 1 down 2, left 1 down 2, right 1 down 6, left 1 down 6, and there's our parabola. So what connections between the axis of symmetry and the x-intercepts? It's between them. Halfway. Exactly halfway in between them. Okay? So we can deal with that. Let's see if we can work this on some of the problems. All right, so this first problem is going to give me the point negative 1 comma 0 and 3 comma 0 because I'd set each of those equal to 0. Okay, so I get negative 1, 0, which is here, and 3, 0 is here. What value looks to be halfway in between them? Yeah, 1. So my axis of symmetry is living right here. My vertex is going to be at 1 comma something, so I'll plug 1 in. So I have 2 times 1 plus 1 is 2. 1 minus 3 is negative 2. 2 times 2 times 2, that's going to give me a negative 8. So I get 1, negative 8. So I'm down here. And I can pattern graph. My pattern graph is going to be 2, 6, 10. Do you see why it's 2, 6, 10? Because of that 2. So if I go right 1 up 2, left 1 up 2, right 1 up 6, it fell right on top of it, of where they cross the x-axis. So that worked out nicely. Let's do the second one. So if I set each of those equal to 0, I'm going to wind up with 3 comma 0 and negative 3 comma 0. So 3 comma 0 is there, negative 3 comma 0 is there. Hey, what's halfway in between 3 and positive negative 3? Negative 3 and positive 3. Yeah, 0 is. So my axis of symmetry actually lives on the y-axis on this one. Okay. Find my vertex, plug 0 in. 3 minus 0 is 3. 3 plus 0 is 3, so 3 times 3 is 9. So 0, 9 is where we're going to live here. We're pattern graphing. The reason why this is going to go down, if I FOILed this out, I'd wind up getting negative x squared. So it's going to be a pattern graph of negative 1, negative 3, negative 5. So if I go right 1, down 1, left 1, down 1, right 1, down 3, left 1, down 3, right 1, down 5. Yeah, look at that. It just happened to fall on those dots. It's not always going to be that way, but it's just nice that it did in this case. Okay, so take a look at the homework on Schoology. If you have questions about this, we will definitely go over any questions in class, okay? Have a great day, my friends. Take care of one another.